Hello folks, welcome in today's lecture. Securing the access to the management network of the devices is always a concern for network administrators. In many networks that are structural, network administrators separate their management network from the data network and call it out-of-band management network. In this lecture, I want to show you that how you could secure the access to your devices. Since I/O devices do not support some commands, I use a regular 3725 router from the routers that I imported into my GNS3. You could use any images that are available for you and are possible to import in GNS3, no matter the platform is. We just want to review the concerns. And I put two hosts. These are not VPCs, these are hosts because I need them, host 1 and host 2. I use two of my network cards, VMnet 1 and VMnet 8, which are added to your Windows when you install VMware Workstation. If you are not installed VMware Workstation in your system, you could add loopback adapters to your Windows. It's very easy. You just go to Control Panel and Network Connections and add loopback adapters. And I assigned two different IP addresses to my VMnet Works. Let me show you. These are my network adapters, VMnet 1 and VMnet 8. VMnet 1 has the IP address in the range of 192.168.3.10, and VMnet 8 has the IP address in the range of 192.168.137.1. And if you install Workstation and you have these two network adapters, the IP addresses may not be in my range. You could use your own range or set these ranges for your network adapters as well. Just remember that the IP addresses must be in the same range that you configure on the interface that is connected to router 1. I put a regular switch and connect my PCs to this switch and connect it to this interface of router 1. At the first step, I want to show you that why we call that telnet and HTTP are insecure protocols and they send their traffic in plain text mode. What is plain text mode and what is the concerns about the plain text send and do not secure the traffic? You always heard that telnet and HTTP are not secure protocols and they send their traffic in plain text mode, but you may not touch this concept. I want to show you this with Wireshark. It's very easy. Let's configure telnet on the device and then we go and see what would happen if we connect to the device via telnet. At the first step, I define a username and password, username Cisco, privilege 15, and the password Cisco 123. And then we go to line VTY 0 to 15 and say that login local to use this username password as the username password which is connected to the device. Now I go to the interface fastethernet 0/0, IP address 192.168.3.20, 255.255.255.0, and no shutdown. Since I connect my network adapters to this router, now in my own PC, without any device, I could ping 192.168.3.20, which is the IP address of fast Ethernet of router 1. Now I want to capture the device, start capture, and this is the Wireshark interface. You see this? And now I go to my device and use telnet command to connect to the device 192.168.3.20. Username Cisco and the password Cisco. Username Cisco and the password is Cisco123. And we are in. Now I want to show you that why we call that telnet is a plain text protocol and it's not secure. If I open up this and review the telnet packets which is captured between us and router 1, you will see the password and the contexts. Let's start from the beginning. Here we connect to the router and we see the prompt of the username. And now we start to enter the username. You see the data is C. It is not encrypted. It's the plain text C. The next one I, S, C, O. And \r/n means enter. And the hacker, which is sniff our network packets, understand that the username is ended here, and from now we're going to start our password. CISCO123 and again enter. You see, this is sending the packets in plain text mode. I sniff the packets from switch 1 and router 1, which was from host 1 to router 1. And anyone in this network could sniff the packets in any way with different methods that are available in networks, could sniff the packets which is transferred between the management station and the network device, and see that and understand the password which is set on this device, and security breach is completed. This is the same for HTTP. Let's go and do it for HTTP as well. We go to router 1 and we enable HTTP server on our device. IP HTTP server and IP HTTP authentication local. With these two commands, we enable HTTP access to our devices. After you enable HTTP server on the device, some of the commands and something could be done via a browser, and the most effective one is using some tools such as CCP, Cisco Configuration Professional, or SDM, or any other management application. I just want to use a simple web access through Internet Explorer. 192.168.3.20 authentication is done. Let me capture the packets first because we stop it. Stop capture, again start capture, and see Wireshark here. This is Wireshark, and we go to web interface and enter our password. You see, this is the web console of Cisco 3725. Some show commands and something could be done here via exec mode. You see, you could here say, for example, show running dash config. The command is run on the device and you see the results here. But our concern is security and sending the packets in plain text mode. Here, if again I open up, you see the credentials Cisco 123, HTTP, just like the telnet, send the traffic without encryption and in plain text mode, and it's very dangerous. So you have to disable HTTP and telnet on your devices, and do not allow the administrators to connect to your devices via HTTP or telnet. If your device or your iOS does not support SSH, you have to upgrade your iOS to support SSH and disable telnet at all. But how we could do that? First, let's go and enable SSH on the device and disable telnet at all. For configuring SSH, first we need a domain. These are the CCNA commands. I'm sure you remember these commands. IP domain name, for example, cisco.com, and then crypto key generate RSA, and the key length. You know that the key length of your encryption key could be from 360 to 2048, and longer key is better for security, but its load on the CPU of the device and the client could be more. It's a trade-off between the security and the loads on the CPU. We choose, for example, 1024, and the keys are generated. You know that SSH uses asymmetric encryption with two keys, public key and the private key. Public key is sending to the clients and ask them to encrypt the packets and send them to the device, and the packets which are encrypted with the public key only could be decrypted with the private key, which is only on the device and nobody knows about this. The next command, enabling SSH version 2. You see here says that SSH 1.199 is enabled on the device. This means that SSH version 1 and version 2 both is enabled on the device. SSH version 2 is more secure and SSH version 1 has some vulnerabilities, so we advise that to enable SSH version 2, IP SSH and version and 2. In this way you enable SSH version 2 only on your device and no SSH version 1 is enabled on the device. It's more secure. Then we have to go to line VTY 0 to 15, which was our telnet and SSH lines, and say that transport input and then only SSH. In this way you disable telnet at all, and on these lines, which are your virtual terminal lines from 0 to 15, which are 16 lines in the devices, only SSH is allowed. If you want to enable SSH and telnet, you have to import transport input SSH telnet. But when we say that transport input SSH, only SSH is enabled on the device and telnet is disabled at all. We could check it. Let's telnet to the device again, telnet 192.168.3.20. And you see that could not open connection to the host on port 23, which is telnet port. Connection failed. And the device does not allow you to connect via the telnet to the router. Now I want to connect via SSH and show you what is SSH done and what's the difference between SSH and telnet. Let's close our Wiresharks and open up a new one. Here we stop the capture and start again. Wireshark is now here. I open up a new tab in my secure CRT. SSH version 2, you see that in applications you could use SSH version 1 and SSH version 2. If you do not enter the command IP SSH version 2, you could use both of these, but since we enable SSH version 2, you could only use this. The host name, for example, 192.168.3.20, and the username is Cisco, and connect. Okay, you see a warning message here because we want to get the certificate or the encryption key from the device, and it is not from a trusted root certificate. The warning message is shown here and asks us the server host key fingerprint MD5 hash is this. Do you want to accept this public key and encrypt your packets with this key and send your traffic to the device or not? You could use accept once only for this session, accept and save, and use it for further connections as well, or cancel if you are not trusted with the device. I use accept and save and enter the password. We're connected. Now I want to stop the capture and I want to see the SSH packets. When you open up SSH parameters, you see only some encrypted packets that does not have any meanings for you. You see that? You see encrypted packet, encrypted packet, encrypted packet, encrypted packet. After the key exchange is done, the packets are encrypted between two devices and they are not interpretable by you. If you want to decrypt these packets, you need to have the private key, which is only available for router 1 and it's not available for you. And if someone wants to break these packets, needs many times, maybe hours, maybe days, maybe months or years to decrypt these devices with some methods. And in security policies, we always need to change our passwords. And this could prevent the hackers to break our passwords. And they need some more complicated methods to decrypt the passwords or gain access to our devices. The same is true for HTTPS as well. If you want to use HTTPS on your device and if you want to disable HTTP on the device, first you have to disable HTTP, no IP HTTP server. In this way, we disable HTTP on the device, and now browser could not connect to the device anymore because the port 80 is closed on the router and it is not answered to the questions, so we could not connect via HTTP. If you want to enable HTTPS on the device to use with the browser or some tools like CCP, you could issue the command IP HTTP secure-server. In this way, you see again some RSA keys are generated on the device and we have new certificates, and if you want to have them on the device you have to use write mem to save your encryption keys, and after this you could use HTTPS on the device. And now we test HTTPS as well with Wireshark to see the encrypted packets. Again here instead of HTTP we say HTTPS on the device. You see, since the certificate again is not from a trusted root certificate authority, we have an error and a security warning for you. This is not from a CA that we trusted. We say that continue to the website and we accept the key for encryption. And now we enter the username and password Cisco123. And there we go, we have the same console with HTTPS, but certificate error is just because that router 1 is not a trusted root certificate that is trusted by our browser. You could use your CAs that is trusted by your browsers, or just accept this certification error. In content, for example, in Internet Options, in Internet Explorer, in Publishers, these are the trusted publishers or trusted root certificate authorities that are trusted by the browsers, and they are updated by Windows Update for Internet Explorer, of course, and for other browsers by their own updates. And since your certificate authority, this is, let me show you who issued this certificate. View certificate, details, certificate path. This is iOS self-signed certificate. You see, this CA root certificate is not trusted because it is not in the trusted root certificate authorities store. And you could import it or use your trusted CA in the network or use the public CAs. And now if you want to see the HTTPS packets, you could use or filter SSL packets, and you see application data here and you see some encrypted data on your packets which are transferred between your management device and your management console or your PC. The other security practice which could be done in your system is restricting the access to the devices. If you have out-of-band management network, it's very good, and you could limit the access to your HTTP or HTTPS or SSH to those out-of-band management hosts. But if you do not have that, you could still restrict the password. For example, assume that host 1, which is on VMnet 1, let me check the IPs again. VMnet 1 is in the range of 3 and VMnet 8 is in the range of 192.168.137. We add another IP address to our interface, fastethernet 0/0, for example IP address 192.168.137.20.255.255.255.0 and secondary. So this host has the IP address in the range of 3 and this one has the IP address in the range of 137. Since we do not restrict the access to the device, and we could connect to the device via this IP address or with this host as well. Let's check it. Again, let's open up a new session. For example, SSH version 2, 192.168.137. I use this IP address as the target because if we use this IP address, our client, these two IP addresses are all in my computer, but since they are on different network adapters, if I want to connect to this IP address range, my computer will use this network adapter to connect it. So by only one computer with GNS3, you could have two network adapters and emulate two networks. I use this again, Cisco, and finish and connect to the device. And you see, again, we have authentication because this time the IP address is changed. We again accept Cisco 123 and we could connect to the device and there is no any restrictions. But we want to restrict HTTPS and SSH as well. Let's check HTTPS to 137.20. You see, again, we have certification error. It's okay. Again, we enter our username and password. And there we go. You see, we could connect with this IP address and we assume that from another client. Now I want to restrict the access to SSH and to the HTTPS only to host 1. And we want to restrict host 2 to access to the SSH and the HTTPS of the device. To do this, we need access lists. So we have to define an access list. I define an access list number 1 and just permit 192.168.3.1, which is the IP address of my network adapter. Let's check it again. Was it 3.1 or not? No, it is 3.10. Okay, we permit to 3.10. We permit host 192.168.3.10, which is host 1. Now we have to use this access list on our entrances. For HTTPS, we go to global configuration mode and say IP HTTP access class and the number of your access class, or if you use named access lists, you use the name of your access list. And for SSH, we go to line. Again, we use access class commands and the number of our access lists. Access class 1 and for traffic in. Okay, access class 1 in. We use this access list for input traffic. Let's go and check it. Now from my PC, if I write the configurations and disconnect this and use this, you see, this time I could not connect to this IP address. This is from host 2. The remote system refused the connection. And this is true for HTTPS as well. If I enter again, you will see this page cannot be displayed. But from host 1, it is possible because we allow this host. See? And this is allow as well. You see, we could enter the password and we are in SSH. So by using access lists, you could limit the access to your devices. Let me tell you 2 little security best practice and finish up today's lecture. The first is using banners. Using banners could be a good way to have good reasons when, for example, a hacker hacks you and for example, in a court you want to complain him and say that we warn him when he connected to the device. For example, some of the network administrators enter, for example, welcome to the device. This is not a prohibited message and it does not say that you could not connect to the device, and hackers could claim in the courts that you do not prohibit me to connect to your devices and some sort of things like this. To define banners, you go to global configuration mode and say that banner and MOTD or message of the day, and you have to use a delimiter. It's not important what character you use it, you just use special character for opening and ending your message. For example, I use A and you enter your message. For example, only authorized users could access, or any other message you want it. And we end it with A again, and then we go to line VTY 0 to 15 and say MOTD banner and enter to enable MOTD banner for this line. And when you connect to this line, you see this message on the console, and this could be used to prohibit unauthorized users for claiming in the courts. The next trick is using service password encryption command. If in this router I issue show running command, if you use usernames and password just like me on your device, you see them in plain text here. Username Cisco privilege 15, password 0, Cisco 123. You could use service password encryption command to encrypt this showing username and passwords. Use service password encryption. And again, if I issue show running command and from the begin username, you see, this time the password is encrypted with Cisco password encryption algorithm. This is not a secure way, because if you copy this message and use many decryption tools which are available in the web and in many network tools, this could be decrypted because it's very, very simple. But at least when someone sits besides you and see your configurations and they are potential hackers, you could hide your real password from them. And the last security practice is disabling CDP. CDP is a very good protocol. We talked about it in the first lectures. We could use it in many situations, and it could give us very, very useful information. But when your device is connected to an untrusted network, for example, assume that you have a router which is installed in an ISP and this is connected to hundreds of customers, and we do not want to let them to do this. I think I show you this command in the CDP lecture, but just to review this, you could disable CDP totally on your device or separately on the interfaces. For example, you have a router which is installed in the ISP and 10 of the networks which is connected is trusted and others are not trusted. So you could disable your CDP on those untrusted networks by going to the interface and say no CDP, enable and disable CDP on this interface. Okay, I think we are done for today. In this lecture, we see that why we say that telnet and HTTP are insecure protocols and they send their traffic without encryption, and this sending has very, very potential risks and they could be very dangerous for the network. And you have to disable telnet and HTTP on your devices, and you have to enable SSH and more specifically SSH version 2 to have more secure version of the SSH and the HTTPS, and how you could limit your SSH or HTTPS access to the device with access lists. And you see how we could define banners for logins, how we could disable CDP on our devices, and how we could use service password encryption command to hide our real passwords from the persons. I hope this lecture helps you to improve your knowledge, and see you in the next lectures.